Hello and welcome everyone to the 5G Factor. I'm Ron Westfall, Research Director here at the Futurum Group, and I'm joined here today by my distinguished colleague, Todd Weiss, our team analyst. And today we're going to dive into our show called the 5G Factor, which is all about the 5G ecosystem and the IoT and the major developments that have caught our eye. So Todd, welcome back to the 5G Factor. How have you been bearing up between our episodes?
I'm good, Ron. Thanks for having me back. I'm looking forward to it. Last week was my initial voyage with you, and I'm looking forward to continuing our exploration of 5G and everything involved.
Thumbs up. And many thanks, Todd. It's great to have you back. So let's dive right in. Now, a hot topic for the entire 5G industry is virtual RAN or vRAN technology and its development. For a level set, we're viewing vRAN as a methodology of virtualizing network functions and enabling them to be controlled by software platforms using commercial off-the-shelf processors or COTS. Now, Open RAN is a methodology of disaggregating the RAN and providing open interfaces. And this extends the principles and objectives of vRAN design. So Open RAN is an effort to open the RAN altogether. The ORAN allowance, for example, is working on specifications to open the interface between the RRU and the DU, and even further between the DU and the CU. So vRAN does not have to fully align with Open RAN per se, although the two are frequently joined at the hip across industry discussions and so forth. So over the last decade, Intel specifically has shown the world that vRAN on general purpose processors are competitive in terms of power and performance compared to a traditional network architecture, i.e. a proprietary one. I believe Intel, though, recently reached a milestone in announcing the commercial availability of its latest and most integrated vRAN solution. That is the 4th gen Intel Xeon Scalable processor with Intel vRAN Boost. And it's the vRAN Boost that's really the new part.
Yeah.
Now,
Can I add something there, Ron?
Sure, you bet.
This is really important that they finally came out with this. It's a big deal. The press release gives all this information. I'm sure you're going to talk about it, but it's incredibly important in the vRAN space, what Intel just announced.
Amen. Yeah, I think that the industry as a whole is receiving it that way, and we'll definitely bring that out more. And as a little background, Todd, this was first launched at Mobile World Congress 2023, back early in the year. And the processors are designed for powering high performance, power efficient vRANs naturally. Now, by fully integrating vRAN acceleration directly into the CPU, Intel has now eliminated the need for an external acceleration card now. So as a result, this design innovation, Intel vRAN Boost, is arguably that breakthrough that you just pointed out, Todd, for the entire vRAN market, let alone the entire 5G ecosystem. So by eliminating the acceleration card, it not only can reduce system complexity, but it can also provide substantial power savings. And we'll definitely drill down on that. In fact, the 4th gen Intel Xeon Scalable processor combined with Intel vRAN Boost delivers up to twice the capacity, an additional 20% compute power savings versus the previous generation. Now, that's a gain of more than double the performance per watt for network operators. And these new processors also include features that optimize workload performance for packet and signal processing, as well as integrated acceleration for our other hot topic of the summer, AI, and naturally machine learning applications. Now, how's this being received, as you touched on, Todd? Well, for example, Rakuten Mobile has collaborated with Intel since the launch of its mobile network in Japan. And the introduction of, I see, the 4th gen Intel Xeon Scalable processor with the vRAN Boost capabilities represents the next phase of their collaboration to simplify telco operations and decrease costs with integrated acceleration and increased energy efficiency. Plus, Deutsche Telekom's tests under selected scenarios showed a 2-fold capacity gain using approximately 20% less power compared to the 3rd gen Intel Xeon processor. And now DT expects this will also enable a reduced network infrastructure footprint among other benefits. So, the generational processing improvements are critical because this is going to help drive naturally the long-term growth of vRAN itself, but also, as already pointed out, Open RAN as well. And we'll see how they're tied together in more examples. Now, at this point, Todd, now what do you see out there that's driving more vRAN innovation? What do you see the mobile operators in particular doing of note?
Well, actually, there's some really interesting things going on now, Ron. What stands out to me is that the Rakuten Mobile has collaborated with Intel since the launch of the Rakuten Mobile network in Japan. And the introduction of this new fourth gen Intel Xeon scalable processor with vRAN boost, I think represents the next phase of their collaboration between these companies to simplify telco operations and decrease costs with integrated acceleration and increased energy efficiency. That integrated acceleration is really important. It gets rid of another component. It puts more things on the chip. It's a brilliant idea to minimize the hardware and maximize the performance. I think it's really a great thing. Now, for Vodafone, the long-term collaboration between Intel and Vodafone is also present. And that's key to the company's target of achieving 30% of its European network on Open RAN by 2030. That's quite a goal, but they're aiming to make it. I believe the fourth gen Intel Xeon scalable processors with Intel vRAN Boost can be a strategic platform to deliver the efficiency and performance needed to deploy Open RAN in dense urban environments at scale, which is a very tricky thing to do. So they're working hard to make it better.
Yeah, and I think Rakuten Mobile definitely deserved honorable mention twice because, as we've seen recently, they had some leadership changes, and but they are staying the course, and this is, I think, a tribute to Intel's capabilities.
Yep, I think you're right.
And with that in mind, what do you see that the vRAN suppliers, looking at them now, are doing to advance, these vRAN capabilities, Todd?
Well, again, Ron, there's a lot of stuff going on. Samsung, one of the biggest players out there in mobile, is expanding its collaboration with Intel, which is a big deal. These are two major companies working together through a new product innovation agreement, allowing the companies together to continue advancing vRAN for enhanced performance and capacity. When these two companies do something together, it's going to make the needle move. As part of their expanded collaboration, Samsung's going to integrate its vRAN 3 software with fourth gen Intel Xeon scalable processors that have that Intel vRAN boost to deliver advanced vRAN products. Offering increased capacity, Samsung's enhanced vRAN will be able to support more cells with the same number of servers, which is critical, which would bring the benefits of power savings and cost efficiency to network operators. This is a really big deal for them. And along with the ecosystem partners, Samsung continues to deliver advanced virtualized network solutions powered by its latest vRAN 3.0 capabilities, such as its 200 megahertz 3-cell support for 64 T64R massive MIMO radios, power-saving features, and improved automation. All these things are really important in this space. This can pave the way for operators to deploy a more versatile RAN solution. And in addition to its enhanced features, Samsung's vRAN also supports multiple radio access technology, which is also called multi-RAT, across 2G, 4G, and 5G, which is giving greater flexibility in network operation.
Yeah, those are all excellent points, Todd. And I'm impressed that you were able to accurately pinpoint the name of the antenna that Samsung is using. And this is all important because, in addition, Intel announced a strategic collaboration agreement with Ericsson to use Intel's 18A process and manufacturing technology for Ericsson's next generation optimized 5G infrastructure. Now, as a part of this agreement, Intel will manufacture custom 5G SoCs or system on chips for Ericsson to create their products for their future 5G infrastructures. Now, additionally, the companies will expand their collaboration to optimize, again, fourth gen Intel Xeon scalable processors with the Intel vRAN boost for Ericsson's Cloud RAN proposition. And now this helps CSPs potentially, again, to increase their network capacity while gaining those very valuable energy efficiency gains, while also gaining that more scalability and flexibility in the process. It's again, it's an across-the-board benefits that are being delivered with these new capabilities. Now, in addition, I view the Ericsson alliance as signaling confidence in Intel's 18A process and underscores the progress that Intel is making with its 5 nodes and 4 years roadmap to regain process leadership. Now, this is ambitious and it's something that really Intel had to do, but we're seeing, Intel CEO Pat Gelsinger delivering. And yes, the journey's not complete, but obviously, Intel had been dug itself into a bit of a hole when it came to process leadership. But this is, I think, showing clearly that there is validation across the ecosystem, certainly with a major player like Ericsson, that Intel is indeed executing on its plan. Yeah. Now, I see 18As as Intel's most advanced node on the company's 5 nodes and 4 years roadmap. And after all, it's introducing new gate all-around transistor technology, also known as ribbon FET, and backside power delivery, also branded PowerVia. And that first appeared in Intel 20A, or will, but Intel will now deliver the ribbon architecture innovation and increased performance, along with continued metal line width reduction in 18A. Now, combined, these technologies could put Intel back in that process leadership position by 2025, potentially augmenting future offerings for its customers when they bring them to market. So again, we're looking at a 2-year span here before the jury can come back, so to speak. But again, this is exciting, and it's showing that execution is advancing. And with that, let's look further afield in the vRAN space for a bit. As we know, Todd, Intel has serious competition in this segment. Marvell, for instance, comes immediately to mind. And Todd, from your perspective, what do you see that Marvell is doing that is differentiated?
I think I've been covering this company for about 4 or 5 years. It's a fascinating company. It's tiny compared to Intel, but man, they are innovative. They are flexible. They are quick to be able to react, and they're doing some amazing kinds of things. From my view, unlike the so-called look-aside general purpose alternative, the Marvell architecture is host server CPU agnostic and uniquely enables RAN. It also has software programmability based on open source industry standard interfaces, which is really important, and also helps them work with all kinds of other vendor stuff. It also has software programmability based on open source, industry standard interfaces, and inline hardware acceleration that delivers feature, performance, and power parity compared to existing 5G networks, which are honestly absolutely critical requirements of mobile operators. And with a comprehensive set of inline 5G hardware accelerators, standard PCI server interfaces, and full Open RAN compliance, software developers can easily leverage Marvell's OCTEON Fusion silicon hardware, or for that matter, any data processor unit or DPU that's compliant with these standards without the need to know its detailed implementation. That is huge. Marvell doing this, it's huge, because what that does is that makes these things easier to use, these components easier to plug in, these components more flexible in any use. That to me is incredible. And that's where a small company like Marvell can take those kinds of leadership roles. They juke when other companies are going the other way. I think that's a really big feature. Furthermore, the Marvell OCTEON Fusion vRAN accelerator in the form of a PCIe card, which is simple to install and use, is host server CPU agnostic, whether ARM or x86 based, and it's supported by multiple OEMs from both the RAN and server segments. Marvell is also working directly with hyperscale cloud customers on vRAN enablement. Bottom line, I just think Marvell's doing amazing things. There is no vRAN alternative that's as open and optimized and widely supported as the Marvell platform. I'm impressed with them so much. It uniquely enables cloud scalability, including integration of the largest cloud orchestration and management software platforms, as well as feature, performance, and power efficiency that is on par with today's most advanced 5G networks. They're really doing amazing things. We're going to be hearing a lot more from Marvell in 5G and many other aspects of technology over the next years.
Yeah, no, this is just great for the entire 5G ecosystem. Clearly, competition is driving at least the chip suppliers, to up their game. And I think clearly Intel has gotten onto the inline acceleration bandwagon, for example. So those are all excellent points, Todd. I fully agree that Marvell is definitely making a huge difference in driving competition in the field. And again, I agree that the inline architecture just has those competitive advantages over what Intel was doing before with what was called the look-aside approach. And so now, operators or cloud providers, whoever else is implementing it, can simply take the SmartNIC capabilities and combine them with the COTS server hardware to gain these advantages. Now, with Intel on the inline bandwagon, with that new offering, again, vRAN Boost, the processing power and capabilities of market-wide inline architecture, I anticipate, will improve through silicon design advances. We just touched on them substantially, and also enable the chipset suppliers, including Marvell naturally, but certainly Qualcomm, AMD, and NVIDIA, as well as Intel today. Of note, now Nokia is an example of a customer that is using the Marvell OCTEON silicon to augment its ReefShark chipset family across those applications such as multi-RAN as well as transport. And when I'm looking ahead, I see layer one processing, L1 processing demands increasing substantially due to higher radio capacity needs and the lower latency demands out there, and the concatenation from 5G standalone to 5G advanced down the road, and ultimately in terms of 6G, in terms of throughput, multi-sector macro cell base stations, microcell base stations, and for that matter, intelligent radio head environments. And go ahead, Todd.
Yeah, there's a lot going on, but what I was thinking when you were talking just a minute ago is that Marvell is helping to push Intel to higher levels, and Intel is helping to push Marvell. The gaps that are there in the marketplace are where smaller companies can quickly come in and do things, but Intel's paying attention. I think this is good for the whole entire semiconductor marketplace because small companies help drive innovation and the big companies realize it and see it, and they may not have started it, they didn't think it was a big enough niche for them, but then they realize that niche is big enough for everyone. So I think this is a really interesting marketplace right now.
Yeah, well point, Todd. And I think that's what we're seeing. I think we have pretty much a consensus here. And as a result, yes, that is, I guess you could say it's a rising tide. And it's important because the majority of operators out there have not implemented 5G standalone yet. And that's going to be vital because once 5G standalone becomes at least, the majority of operators effectively becomes the mainstream implementation, then we'll see 5G actually living up to some of the hype that came out with the technology when it was first being deployed about 4 years ago. And so this is critical. And we see this technology as aiding that overall process. It's clearly a journey. We know, for example, in the US, that CapEx has been dialed back by at least two major operators, i.e. Verizon and Deutsche Telekom / T-Mobile. And so, yeah, they're catching up on, the mid-band spectrum investments they made and so forth. But it's a breather, same with Dish Network for that matter. But they are going to have to, again, put the pedal to the metal to at least, get the full benefits of their investments by having 5G standalone becoming more widely available. Now, T-Mobile is already there, and that's one reason why we're seeing T-Mobile registering a lot of success across the major metrics in terms of subscriber counts, in terms of financial performance, and so forth. So that's definitely providing a level set for the other competitors out there, not just in the US, but in other markets, to say, hey, we need 5G standalone to emulate some of the success that T-Mobile has been having so far. And so with that high note, that's a wrap for today's 5G Factor Show. Todd, again, it was certainly rewarding to cover these hot 5G topics with you today.
It was great. Thanks a lot, Ron. I look forward to the next one.
You bet. And thanks again, everyone, for joining. To our viewing audience and our listening audience, as always, thank you for spending time with us. And we look forward to seeing you again next time. Good 5G day, everyone.